Hello everybody and welcome to example 1. We are still looking at page 60 in the workbook here. This is going to be another example of finding the derivative of a function using implicit differentiation. Okay, so let's read this together. Let x squared plus 3xy plus 4y squared equals 4 and find y prime. Notice that we've got a graph of the function over here, and this is the graph of an ellipse, so this y prime that we're trying to find is going to give us a formula, a way of calculating the slope of the tangent line to that ellipse at any point. Okay, so before we dive into the problem, let's just review the key steps. We're going to be following the same process that we did in the preliminary example. Let's scroll up and just remind ourselves what the key steps were here. Okay, so we started in this problem by letting y be f of x to remind ourselves that the variable y is representing maybe several different functions. Then we took the derivative of both sides with respect to x. We did some algebra. And then last step was to algebraically solve for the derivative. Okay, those are the three main steps that we're going to do in this problem that we're looking at now. Okay, so let's do those things in order. We'll start by letting y be f of x. Okay, so every y that we see, we're going to replace with an f of x. Then we're going to take the derivative of both sides. Okay, f of x squared. Okay, over on the right, we've got just the derivative of 4. Okay, and now we're ready to take some derivatives here. Okay, so starting over here at the left, we want the derivative of x squared. That's just going to be 2x. What about the derivative of 3x times f of x? Okay, what's special about that? Well, notice that that's a product of 3x times f of x, so we're going to need to use the product rule there. So let's see, we're going to get the first times the derivative of the second, and the derivative of f of x is f prime of x, plus f of x times the derivative of 3x, that's just going to be 3. Okay, so we use the product rule there. And now we come to this term, the 4 times f of x squared. The 4 is just a constant, so it's going to come along for the ride. And then what do we get when we take the derivative of f of x squared? Well, notice that that's a chain rule. Okay, the u is the f of x. So when you take the derivative of u squared, you're just going to get 2u, so 2 f of x. And then the second piece of the chain rule says take the derivative of the u, that's going to be f prime of x. Okay, and then finally, over on the very right-hand side, what's the derivative of 4? That's just 0. Okay, because 4 is constant. All right, so we've taken all of those derivatives, and just reminding ourselves, we made a choice up here. I actually didn't write it down. Let me do that now. The f of x that we wrote was really a placeholder for y. Okay, so everywhere that we see f of x in this formula that we came up with, f of x is really representing y. So we'll replace every f of x that we see with y, and every f prime of x with y prime. Okay, f of x times 3, that's y times 3, which we could write as 3y. And then let's see, 8y prime equals 0. Okay, so we've taken our derivatives. Very last step now is to solve for y prime. That's what we're trying to find here. Okay, so this becomes an algebra problem now. Okay, now this is a little bit more challenging than it was in the preliminary example, because you might notice that we've got y primes in two different places in our equation, one there and one there. How do you get the y prime by itself if it's in two places like that? Okay, well, you might remember this when you see it from algebra. What we can do is use the technique of factoring. So what we'll do is to take all of the terms that don't have a y prime in them and move them to the right side of the equation. So we're going to subtract 2x and we're going to subtract 3y from both sides here. Okay, we can do that if we do it to both sides. And if we do that, what's left over on the left side is just 3xy prime plus 8y prime. Okay, and then the 2x and the 3y that we subtracted over are going to become minus 2x minus 3y on the right side of the equation. So what we've done is just to get all the terms that have y primes alone on the left-hand side of the equation. Okay, what do we do now? Okay, well, here's where we can factor. Okay, the terms on the left side of the equation all have y primes in them, so let's just factor a y prime out of that. If we pull a y prime out of the first term, we're going to get a 3x. If we pull the y prime out of the second term, we get 8y. Okay, so y prime times 3x plus 8y equals negative 2x minus 3y. What's the last step here? Okay, we can just divide both sides by 3x plus 8y. Okay, and that'll get the y prime by itself. So y prime is equal to negative 2x minus 3y over 3x plus 8y, and there's our answer. Okay, and just a reminder what the meaning of that is. Okay, y prime, that's the derivative, so this really represents a slope. You could use this formula that we came up with to find the slope of the tangent line anywhere on this ellipse that we're looking at over here on the right.